Hi, this is class 6 of my Oracle SQL for Beginners course. My name's Ken Ma. You can mail me with any queries here. And as it's class 6, we're well into the course. If I look at the contents, this section is multi-table retrieval. We did 1, 2, 3 on those, 4, 5, and this is 6, 7, 8, 9, 3 to go. So this looks at using calculations in a select statement. Use some column aliases in a select statement, running multi-table queries, which is joining tables together. That's the main part of this. And different ways of doing that, including using the ANSI 92 join syntax, which includes outer joins. Also looks at creating and using views and flashback queries. So I can move this over a bit like that, and then I get a bit more of the SQL. This is SQL Developer. See, I'm logged into the database as user 35, a cloud database, and I've opened here a sample file as we did in the last class. This open file, the sample file is x3 multi-table SQL. So let's look at what this covers. It starts with calculations. You can use plus, minus, forward slash and asterisk in a calculation, but what you get back depends on order of precedence. If you're doing something simple like this update, which updates the cost price by 10% and the selling price by 15% on the product table for that one row, so I get back one row updated. However, this one has a calculation which mixes minus, divide and multiply. Now that sort of thing, if you don't know what you're doing, returns the wrong answer. For instance, on a ThinkPad, which costs that, sells for that, we don't make up a markup of 1000%. This is the percentage markup. Sorry, that's the percentage marking, isn't it? That's the markup, I beg your pardon. The markup's the difference between the two. Sell one at cost. That's the margin. What you need to do to get the right result with that is to know about order of precedence and what's called Botmas. And the way operations work is left to right, but they do it in this order, which you can remember with B-O-D-M-A-S, Botmas. So brackets first, anything in brackets is done first. So that one is correct because it's 5 plus 3 is 8 times 6. It's not 6 times 5 plus 3, which it would be if you didn't have the brackets in. That's why I've got the brackets in there. Maybe they shouldn't be in there. Let's take them out. You have an idea of what I mean. To get the right answer, you need to bracket that. If you don't bracket it, you get the wrong answer because it does the multiply first. After it's done brackets, it does orders, powers. So 2 squared, for instance, which we'll do first. So the right answer is 5 times 4, not 10 cubed, not 2 times 5 squared. After it's done those, it then does divide or multiply, follows that with add and subtract. But the gist of it is to get the right answer here, to make sure that it does sell minus cost and then divides it by cost times 100, cost and then times 100, you need to bracket sell minus cost. And if you do that, you get the right result, which is, you can see, for this one, 18%. Now, you get a lot of decimal places if you do that. You can remove them very easily with the rounding function there. All functions take parameters in brackets, so you put the calculation there. We want it to 2 decimal places, and we get 17.5, which makes more sense because it's rounded it up. Now over the page, oh, there's Botmas explained again, B-O-D-M-A-S. And the fact that if you don't put brackets around that, like that, you don't get the right result. There's a rounding function, rounding it. The other thing is column aliases, which we did look at earlier. Here, cell minus cost is a column heading, and that's the column heading. You don't normally want that. Now what you can do is you can have a column heading in lowercase, which uses an underscore. You can't put a space in it to mark a space. It'll come out in uppercase, which they always do, unless you put them in double brackets, in which case you can use a space and you can use mixed case. It depends how you want your report to work. I mean, mostly I do it like that. I don't mind all the headings being in uppercase, but you might have users who want reports written with the headings in mixed case, like that. So there's markup and markup, column aliases. Now the exercises in this section look at data arithmetic. It's the same sort of thing, although you're not going to multiply and subtract dates. Sorry, multiply and divide dates, you can subtract dates. When you do arithmetic on dates, what you get is a difference in days, and if there are times involved, you get a fraction like this. Now the reason you've got that, well, there's a time involved, you can't see that with the default date format. What you need to do is use to char, as we did earlier, and reformat the date to use perhaps hours, minutes and seconds, like that. Now you can see that there's a time there and a time there, so when it takes the dates away, you get a fraction, which here has been rounded to 2 decimal places. Now the exercises are always based on what we've just done, so the exercise here is very similar to this example. From the rental table, find the member ID, film ID, date rented and date returned. You can see them if you click on rental there. These are date fields. You can see that if you click on the table and look at the columns. They're dates. Then add the number of days, which is the difference between date rented and date returned. Round the number of days to 2 decimal places and restrict the display to all films that have been returned. And don't remember, if you want the answers to these, if I go back to the SQL field, the answers are in that file there, which is answers spelled backwards .sql. Now let's move forward and look at using aliases. Aliases don't have a lot of use really, except as column headings. You can't use an alias in a where clause, for instance. Here you can't say where margin is greater than 50. There's the alias there. That fails with the error. Margin is an invalid identifier. It thinks margin should be a column or a calculation using columns. To get that one to work, what you have to do is use cell minus cost. And that works. There is a use of margins in the order by. You can put margin in the order by as I've done there. That's one place that can be used. You can also put there the number the column appears, counting from the left. So 1, 2, 3, cell minus cost is the 4th column. So I can put a 4 there. That will work. So that's another use of Well, it's not, is it? It's a different way of doing order by. Little exercise there. Now, as I said, most of this section looks at joins. So here we'll look at joins. Just need to undo what I just did. That's it. So it stays back as it was. Now, let me take a copy of that and put it in another window so I don't mess up this file. I'll put it in the query window there. Paste. Get rid of that one. That's interesting. Oh, semicolon. What this does, it joins together the two tables, supplier and sale order, in an effort to find the orders ID, the date order from a sale order table, name and town from the supplier table. Now, it doesn't matter what order you put the extra tables in your select clause. If you're, I mean, it used to, but it doesn't matter now what order they go in. You can put the column names in the order that you want to appear. You put the table names that the columns are on in any order. And if you're selecting, see, up to now we've only done single tables. If you need columns from more than one table, you put them in the where clause. Now the problem is, what you've got here, I hope, is 99 rows. Yes. And the reason you've got 99 rows is because on the supplier table there are, in the data, whoops, beg your pardon, in the data there are 9 rows, and we're joining with sale order, and the sale order tables there are 11 rows. 9 times 11 is 99 rows. This is what's called a Cartesian product, because it's what it's done is it's joined the rows in the order table to every row in the supplier table. So you get the order 100 belongs to comment, but so does 101. But 100 also belongs to Dell, so does 101. It's obviously wrong when you get Cartesian products, and it's usually due to not joining the tables together properly. Now these tables join together on their common columns. If we look at supplier and sale order, they join, as you remember from the diagrams we did, from primary key, which is sup ID on supplier, to foreign key, which is sup ID on sale order. So you might think you could, in a where clause, just say where sup ID equals sup ID, i.e. you're joining sup ID on one table to sup ID on the other. Now that won't run because we've got what it sees as an ambiguously defined column name. If a column appears on more than one table, you must prefix it and tell it where to pick it up from. So what we need to do, or one way of doing it, is put supplier dot there, sup ID from the supplier table, join it to sup ID in the sale order table, and then we get the right answer. Now there's only 10 rows instead of 11, although there are, if you remember, 11 rows on this table. That one's invalid. We found that with the outer joins we did. And the reason it's invalid is it doesn't exist on the supplier table as a supplier. So it can only join the 10 rows which have got valid suppliers. Now there's another way of doing this using what are called table aliases. This is a better idea because it saves space and it saves typing the table number over and over again. You can put here a name, rename the table for the purposes of this query. And they don't have to be just single letters. You can put what you like there, but I usually use something short and meaningful. S for supplier, SO for sale order, and I get the same result. What you can't do, however, is mix and match things. For instance, if you join product to sale line and you rename product there as P, it won't run if you then use the product table name. You have to use the P. And the same thing will happen here if I use supplier. Big error message, but basically what it means is you've renamed the supplier table, so you have to stick with that name. So this runs. Suppose you want to add something to this like supplier ID, for instance, which is the join column. We could tack it in there, sub ID, and what we get is our ambiguously defined error again. That's because sub ID is on both tables and it doesn't know where to pick it up from. So anywhere you use a column which is on more than one table in a query, you have to prefix it, tell it where to pick it up. As in the example here, you can't put prod ID there because you're joining it on both tables. You have to prefix it there. And the other thing you might want to do with joins is walk around the database. For instance, if you want product ID and description, which are on the product table, supplier ID and name, which are on the supplier table, you can't get from product to supplier without going from product to sale line to sale order to supplier. So you might have to go through tables even though you don't want any columns from those tables. Like that. This is where the diagrams come in handy. Back at the end of the notes, where are we? We're on page 112. If we go to the end of the notes, there's the films diagram. There's the entity relationship diagram for orders. So you go from supplier to sale order to sale line back to product in the join there, and join the four tables together. Can't remember what I said now, 112 I think it was. Whoops, it's not 112 that side, is it? Sorry, 112 this side. Now a couple of exercises here. The first one looks at joining product and sale line. Read through the exercise, also read the hint, because now as well as columns selected it's tables, more than one, and you might need a join, you might read a restriction, the where clause, and you might need an order by. And the second one looks at the rental table and member and film. Okay, let's look at ceiling and floor. That dropped down there, didn't it, when I see, it went to the line number that I picked. I've lost where I am now. Here you go, this is joins. There we go, ceiling and floor. If you look at this query takes sell minus cost and rounds it. It also gives you there sell minus cost with the decimal places. But suppose you want to go up or down to a whole number. You can do that with ceiling and floor. So round the cost there. No, not round the cost, beg your pardon. Take sell minus cost, which is the margin, there. Round it, it will go up. In fact, they all go up, except that one, which goes down, because 0.12 is less than 0.5. It's unfortunate, but it doesn't matter. So they all go up. Now if you want to force them to go up, including that one, instead of round, you use ceil. And what ceil does, it goes up to the integer above. So these all go up as they did when they were rounded, but 157 goes up to 158. And if conversely you wanted them all to go down, which you might do, you use floor. And here these all go down to the integer below. Now this uses, for instance, if you're calculating somebody's age and it comes out at 66 years and 5 months, you might want to floor it so that their age is 66 and remove the decimal. You can add that to the exercise solution in the exercise there. Now these queries, this query, we take that back to where it was when we started. That will do. That runs. Gives me my oh, I missed the O out. That was Cartesian product because it's joining S to S. Should be S to SO. There we go. Gives me my TED rows. There is another way of doing this. This is called an implicit join notation, where you use a where clause and they're implicitly joined. The other way of doing it, which a lot of people prefer, is using ANSI 92, which is a new standard. It didn't come in until Oracle 10G, so if you've got a lot of old databases running Oracle 7, 8 or 9, joins only work this way, which is why I always do it this way first. But Oracle now support this ANSI standard, and the way this works is you do an explicit join notation using the join keyword. It's very easy to change this into that. What you do there, you say in a join instead of the comma. And here, you say on instead of where. And you get the same result. So you're now saying join from supplier, do an inner join on sale order to sale order on supplier ID on one table equals supplier ID on the other. In fact, inner is optional. You don't have to say inner join, you can just say inner join, sorry. It does it. There you go. Now it points out here it doesn't matter which syntax you use, whether you use the where clause or whether you do it this way. There's no difference, and it's no more or less efficient to use one of them. Provided all the joins are inner joins, not outer joins, which we'll look at in a minute, then it doesn't matter. But a lot of people think this way is better because the join is explicit and it's clearer. And one reason it's clearer is there's an exercise there rewriting what we've done with this join syntax. The reason it's clearer is you can add things like a where clause and it's separate from the join. So here I could say where if I did order ID, which is only on one table, I think, is greater than 104. This is possible when you're doing this sort of thing and joining these tables together in there, right, you get that back. What people tend to do sometimes is in there they'll say and let's add cost on, just to make it easier to add a where clause. They'll say something like and cost, whoops, is greater than 500. Now that works fine, but you've got your where clause in there in effect and your join clause here and here and here, and it's just messy. You can't do that if you do it this way. You have to put the join first and then the where clause. And in fact, if you want to join to no, that's the same thing, isn't it, that we've just done. There we are. If you want to join to another table, you use join and on for that. So from here we can say we're going to go onto sale line, and if you want to tab it in, it just makes it easier to read. We can leave out the word inner. We can say join sale line and call it, I've called it, that's not an A, is it? Close. Join sale line, and we'll call that one SL on SL dot order ID is equal to SO dot order ID. Now that may or may not work. It doesn't work actually. The reason it doesn't work, I've got to begin this column again. We've just added order ID on two different tables, but we've used it there, so we have to prefix it there. And we've still got a biggest column, that one. That's better. Then it works. So you have to watch for that. You know, order ID there doesn't have a prefix. Here it needs a prefix. What some people do is they prefix everything. So that's on SO. Whoops, SO dot. Beg your pardon. That's on S dot. That's on S dot. If you do that, you can't go wrong. You won't get ambiguous errors because you prefixed everything, so it knows where everything is. Right, now we'll look at outer joins. Okay, we'll take this back a bit, I think. Take out the extras, the extra join and the where clause, just to make it easier for you to understand what we're doing. There we go, we're back there. Okay, now that's an inner join, so it joins sale order to supplier on supplier ID if there's something there to join on. And like I said, what you don't see is there's no supplier COMP, so when you look at sale order, you don't see that row comp because there's no comp to join on. Now to get that row, you can use what's called an inner join. Sorry, an outer join. What am I saying? An outer join. Sorry about that. Right. An outer join comes in three different versions. You've got a left outer join and a right outer join. For a table to qualify as a left, its name has to appear before the join column. So if it's a left outer join, you're looking at supplier and saying, show me all suppliers, whether they've got orders or not. Now what we want is all orders, whether they've got suppliers or not. So really, we want the right outer join. You can say outer. Let's put it in, then we can take it out again, like that. Now what you get now is all orders, whether they've got a supplier or not, which includes 109. No supplier name because supplier doesn't exist. That's an outer join. That's a right outer join, and we don't need the word outer. Take that out, get the same result. And we can turn it round and say, show me all suppliers, whether they have orders or not, by changing it into a left outer join. Like that. Now if you check the figures, there are two suppliers, Gateway and Orbit, who don't have any orders. Go back there and look at supplier. There's Gateway, Gate. There's Orbit, ORBT. Look on the order table and they don't appear there. So if you do a right join, you get them. You can actually fill things in here if you want in these null values. there's an example there, which is probably in here. If we have a look. There. That's an outer join, but it prints unknown in the supplier name. And that does the same thing, but the other way around. It all depends which way you put them. You get the same answer, but it's the other way round. There you go. Beg your pardon. You don't get the same answer because they've done it the other way around indeed. That is the other way around. Let's go back to this one. We did MVL earlier, so you can use MVL to fill things in there, like that. Or if you're doing it the other way around as a right join, as in the example here, to put something like unknown supplier in supplier, wrap MVL around the name, and it will print unknown supplier there. I won't copy it across because it doesn't copy the quotes properly. And then there's a little exercise looking at that. There's a right outer join, which, as we've just seen, is basically the same as a left join, but does it the other way around. So the right join says all orders, whether they've got suppliers or not. The left join says all suppliers, whether they've got orders or not. So you get these two suppliers. And in fact, if you switch the table nouns, it's around here. It's the same thing. If I make that supplier S and I make that sale order SO, and the previous one, result is showing is a left join. If I make that the right join, I'll get the same results. So it all depends where you put the tables, because this is all suppliers, whether they've got sale order or not now, because it's a right join. The name to the right of the join clause. I can't spell supplier. Beg your pardon. There we go. So it all depends where you put the tables, whether you need a right or a left join or not. And then of course, what we're coming up to is a full join. If you put full there, you get both. So it's all orders, whether they've got suppliers or not, and all suppliers, whether they've got orders or not. So there are gateway and orbit, suppliers with no orders, and there's 109, the order with no supplier. And again, there's another exercise on that. Back in the example file, hopefully, somewhere I put a load of stuff in there which we don't need to look at. Where's it gone? Just bear with me a minute. That outer join that we're looking at in the notes there is here. It's obviously in the wrong place in this file, so I'm just going to move it. I've only got one hyphen there now. We need two. Right, they go back up to where we were, which was here. Outer joins. Oh, I see what I was getting at actually. Outer joins is here. This is outer joins. I beg your pardon. We don't need to copy that. This is how Oracle used to suit outer joins. This still works, but you don't have to use this from 10G onwards. However, if you've got an old database running 9i or 8, this will work. There's my joins, my 11 rows with my unknown table there, because that's a right join. There's my unknown, the other one with the two. Actually, that's not, is it? I beg your pardon, that's my fault. That isn't what we want at all. Bear with me a minute. Right, sorry about that. I sorted it out now. This is what we want. Right, this is similar to what we've got in the notes here. So we're looking at joining sale order supplier there. This is the same query twice, you probably noticed. Not an outer join. Now if you do it with the where clause, you can make it an outer join. This is how Oracle used to do it for older, still does it for older releases. You put a plus sign one side. And what that says, show me all orders, which is this side, plus suppliers, whether they exist or not. So you get unknown supplier there. And here, you can't put a plus both sides, but you can put a plus the other side, and that gives you the other one, which shows you all suppliers, whether they've got orders or not, which is the plus here and the plus there. Like it says, this is an old way of doing it in Oracle. And then if you wanted a full join, what you had to do, we haven't done union yet, but we will in the next section, you union the two queries together. And there you get 109, unknown supplier, and gateway and orbit with their unknown orders. So that's an old way of doing outer joins, which only works for Oracle, whereas the other syntax works for most databases. Okay, so over the page we're going to look at views. A view is a stored query based on the select statement. If you remember, this user, or our users, have got 4 sets of tables. But if you're using user 77, user 77 doesn't have any tables. It's a read-only user. It's only got views. So tables it can see via a view. And a view is a query based on your tables. Usually quite a complex query, because you can write the query with its complexity and give it to a user, and the user thinks it's just like a table. This simple example, there's a view. So this is the query. If I highlight that, I can run it like that. So that's what my view is going to give me. It's John Smith, but that's his full name, concatenating, if you remember, first name with last name. Also his male, manager, gender and birth date from employee. Now if I create or replace the view, give it a name, vemp, the view is created as an object within the database. So if I drop that down and that, bring tables back up, drop down views, there's my view there. And you can click on that and see the view. Now the view can be treated like a table. Select from a table, select the table with a where clause, and you can join to it. There are restrictions on updating it, but you can treat it like a table, and sometimes users don't know the difference between a view and a table. The reason I've done create or replace view there in the view is that if you just say create the view, don't do or replace, and you make a mistake and you want to rerun this, you have to drop the view first. But if you do create or replace, you don't. You can just replace the view. And you'll find the views in things like tab and user views, which for some reason in this file are further down the page, I think. Or not there at all. There's user views there. Not sure I put it there. Let's, while I'm here, bear with me. Let's move it and let's put it there. That's the equivalent of clicking here, and what you can see is the text that created the view. You can look at tab as well, here, and I just list names. So there you get the name of the view and the fact that it's a view. You can create a view on any select statement. You can also do things like derive columns in a view. Here's another example of a view which does a join, like the one we just done. And then the user can just say select from view order by 1, and they get back the joined tables. This one is the same as here. This creates a view with a calculation. So it's order ID, description, quantity times cell, joining product to sale line. So it gives you the value of each sale line order. Now that won't run because if you do that, it doesn't know what to call this column. And it quite likely says down here, you must name this expression with a column alias. So there we have to put a column alias in. Then it will create the view. And we can just select from the view in the same way. There's our line values. You can actually rename all the columns in a view like this. If you put new column names in brackets after the create statement, make sure you do it for each column. I don't think you can miss one out actually. Let's try and see. No, it wouldn't make sense, would it? No, you can't. That view has been created, but what's happened now is these are the new column names. So when I select from it, I get order number, description, value and product. So you can do that in place of using a column alias. So I didn't put a column alias in this one, I renamed it as the value there. They're quite simple views. The last thing on views, there's two things you can do. One is have a read-only view, which is there. So that's easy. You just say with read-only, and then whoever's looking at the view can't update it. Now if they can update the view, sometimes it's best if you put a check option. The idea being here is that although data modifications made through a view are not checked to determine whether or not the rows will be within the definition of the view, i.e. if you update the rows, will they still appear when you run the view? You can make sure they do appear when you run the view if you use the with check option. I'll show you how it works. So we create a view, simple view here, viewed, which just selects from product where the cost is greater than 400 with check option. So that recreates field, and then we can select from it there. Now this is only rows where the cost is greater than 400. Now suppose we try and update the view and set the cost equal to 300. If that was allowed to happen, when you ran the select on the view, you wouldn't see that row because the check option, if it wasn't there, would allow that update and that row wouldn't appear because it's cost greater than 400. If you do it this way, you can stop that happening. It violates the check option because we're trying to update it to 400, and then when we run the select on the view, you wouldn't see the row. And that's what the check option does. Oh, this I quite like. This is called a flashback query. When you update the database, Oracle keeps before images of everything you do. It doesn't keep them forever because it will run out of space. But they are there and you can get hold of them. Here's a simple example of a flashback query. If I look at sale order, date order is the 2nd of February. Suppose we update it to today by setting date order equal to sys date, but only for order 108. So order 108 looks like that now. If you remember, I can roll it back and it will undo that update, and it's gone back to 2nd of February. But suppose you did the update and committed it. Rolling it back now doesn't have any effect. There it is, set to today. Roll it back. It's still set to today. But what you can do is what's called a flashback query. You use this line, as of timestamp, a date minus an interval. An interval can be in minutes, hours, seconds, years, I suppose. Well, I wouldn't go back that far. So what you're saying here is, find me 108 again, as of sysdate minus 5 minutes ago. So 5 minutes ago, that row looked like that, 2nd of February. And as we'll see later on, you can actually do a correlated update and correct the data back to how it used to be. Now, I'm not sure what all this, I'm not sure what that's for there. It's not in the notes, so it's probably not important. Materialized views was the next thing. Let's move that. It's probably a leftover from something I used to do, and I don't throw things away. I just tack it on the end of the file in case I want it again. Right, let's look at materialized view now. A materialized view is different. Materialized views are used in data warehousing to speed up retrieval of data. And the way they speed it up is, whereas an order, in a simple view is based on the underlying tables. So if I create that view, that's based on the underlying tables. If the underlying tables change, the view changes. The materialized view is, yes, based on the underlying tables, but it stores the data at the same time, which means it's done all this joining. So if you try and retrieve the data, it knows what's there, so it's very quick to retrieve. Obviously, if you update the data, it won't change. You can see that here. This is V order. This is MV order. They're exactly the same. But if I delete rows from cell line, I don't have to commit it. Oh, I put that in there actually, because the rows will have changed for this user. Now if I look at V order, it's only got 14 rows. Let's prove that. Whereas M order, the materialized view, hasn't changed because it's not changed based on the underlying tables as they change. It's based on a fixed underlying table when you created the materialized view. And like I said, it's used to speed up retrieval. I'll roll that back actually. So that's a materialized view. You can try that yourself. There's one last thing, which is a merge command now. This is useful if you want to do an insert or an update. And the reason it's here is because it uses a join. Because we did insert all in the last section. So what the merge does, it says we're merging into the supplier table by selecting from another table called type. If we find a match in the supplier table, we do an update. If we don't find a match, we're going to do an insert. To show you how it works, I need to create some tables. You can try this yourself. So here I'm creating 3 tables and then inserting into the type table and selecting from the type table at that point there. Run that as a script, and that's what's in the type table. Let's move that up a bit. Now the other 2 tables, customer and supplier, empty because I haven't inserted anything into them. I only inserted into type. Type's got 3 rows into it. 2 of type S and 1 of type C. So 2 suppliers and 1 customer. So what you do now is you say, hang on, yes, actually this is still setting the data up. We did this earlier. We're going to do an insert all, and if the type is customer, we're going to go into the customer table. If the type is supplier, we're going to go into the supplier table. So we should get 2 suppliers and 1 customer, like that. 3 rows inserted. If we look at supplier and customer, there we've got 1 customer, 2 suppliers. Now we need to change the data slightly before we do the merge. What we're going to do is going to have a new line into type, which is a new supplier of S, which is Comet. Add that row. We're also going to update type for WXYZ, which is that one, and change the credit rating to a C. So if we look at type now, it's slightly different from what was in supplier and customer, because XYZ has got C now and Compt doesn't exist in these 2 tables. So we've got a new supplier and 1 to update, because XYZ there was B, Compt didn't exist. So what you do now is a merge. So it looks at supplier, looks at type, joins them together on type ID. If there's a match, then it will set the credit limit. So the credit limit in the supplier table to change to a C, which is what it is in the type table. If there's not a match, which is the new supplier COMT up here. Oh, that was in the other window, beg your pardon. That's in this window, COMT, that will be inserted in here. And if I then run the merge, because that just says merged records, we then to look at supplier and customer. Well, we're looking at customer as well. There's supplier. There's our new supplier, Comet, which was inserted. Oh, we don't have to look at customers actually, because we only made changes to supplier. And there's XYZ, which is changed to a C, because what we had in the type table there, the only changes were to change that to a C and to add comment. The other 2 rows are the same. And that's a new query that came in at 10G, I think. A new way of, it's clever, allowing you to update, say, a customer table with new details if there's nothing there, but update the details if a customer exists. There's an optional workshop at the end of the section if you want to have a go at that. And the next thing I'm going to look at in the next video is functions. So, in preference to that, I'll go back to the beginning. That was class 6. The next one, functions, will be class 7. Alright, thank you and goodbye.